I'm going to report back from the Technology and Infrastructure Group. It was a very enthusiastic group of people. About more than 20 people joined the discussion. And I think everybody volunteered to participate on an ongoing basis, which is fantastic. So I'll do my best here, and please, those of you who are in the room, feel free to amplify. So we actually started out by talking about what are the goals, similar to the comments just made. What are the goals of this project? So I think there was agreement that GP Wright needs to agree on a grand challenge, because for one thing, it needs to be not only to direct the progress, but to be able to state when it succeeded. The Genome Project succeeded several times, right? So that was supposed to be a joke. There was reasonable agreement that this should be to synthesize a human genome that's maintained in a host cell. I think everybody thinks that that's an important part of the statement. Should be achieved in about 10 years. And there's some discussion whether it's actually perfectly reasonable for this to be a copy of some existing human genome that we know works. Because you'll only know you'll only know once you've learned what the genome can do without what you would have put in there otherwise. So if you start using experimental genomes, it's going to be a lot harder than a copy. There was some discussion with it, which I think is unresolved, whether one also needs to have, in addition to that sort of singular goal, some testbed objectives to answer the so what question. So what if you can copy a human genome? And so if we do this, we do need to ensure that those examples don't limit the technology directions and obviate the development of technologies that are needed for other kinds of applications. So it's probably true that one could brute force copy a human genome using existing technologies and get that done in 10 years. It would not obviously be desirable. And if that's all that we do, then the project isn't a success. So you need in your statement of objectives some sort of a bigger goal than what we know today how to do. How to achieve in 10 years. And so maybe the goal would be to say, if we could brute force it today for X cost, then our goal is to be able to do it for 1 over Y cost, for some significantly smaller fraction, orders of magnitude. We need robust sharing of data and materials. We need technology to support the archiving of large constructs. We don't actually have good ways to do that today. And we need standards for representation of the constructs in order to make that sharing most effective. So we have something of a wish list. That was as far as we got. We certainly didn't yet get to prioritizations. I'm sure we don't yet have a complete wish list, but here are some of the things that people in the room came up with. The $1 genome synthesis. I don't think it was meant as a joke. Well, a big genome, a 6 gigabase genome. Synthesis, the ability to synthesize any sequence, including the ones that today are difficult, the ones with palindromes or homopolymers or repeat sequences. Significant enthusiasm for shortening. Turnaround time, not a surprise. Someone said the compile time is currently weeks, even for small constructs. We need the computational tools to make it faster and more flexible to design and synthesize genomes with the sort of the paradigm of a 3D printer. We need at least, just throw out a number, 10x longer error-free oligos, and people talked about it would be great to have 1,000 MERS that were routinely error-free, but we should be shooting for something much larger, like 10 KB. We need. There were many votes for assembly improvements. Not surprisingly, fragments over 3,000 base pairs. People thought it was important to develop the ability to multiplex and parallelize synthesis. Large construct amplification methods and or packaging. transfer of large DNA, automating assembly and getting DNA into cells, getting and maintaining some of this is there's redundancy here, but I wanted to make sure. I think people had different ideas, so I'm perhaps being a bit redundant. Getting and maintaining large DNA in cells, and we're talking about 10 megabase pieces. Though certainly you'll want to be able to develop in the interim host cells with intermediate capacities. Stabilizing engineered constructs in living cells, again, some redundancy here. There was agreement that later, and during the course of the project, we really do need to understand which, if any, repeats, for example, are needed. This would be good toward defining the minimum genome. The ability to make available universal chromosomes that people can use at will, and to turn those chromosomes on and off at will. And another sort of a dream was a foundry on a chip, so that your foundry isn't multiple rooms full, but microfabricated systems. So that's what I was able to capture from the many ideas that were bouncing around the room. And I'd invite other people in the room, in the last 2 minutes that we have, other people who were in the room, to add major things that I left out. And by the way, I will send this summary around to those of you who are in the room, so that you can annotate and add to and so forth. So are there other things people wanted to add, major things I missed? Okay. Okay.
Get all the
Great.
comments, get a final copy, and
Super.
really putting it up on the website.
Super. Okay. Thank you. Yeah.
So I'm a little bit confused because I thought you contradicted yourself. At first I thought you said you wanted us to make wild type, whoever that is, right? But
A wild type.
But then you said that wouldn't count because it doesn't. Or if I understood you right, can you just clarify that? Because
it would be.
I remember distinct discussion with funding agency about synthesizing the yeast genome and having them say, you're just going to remake wild type? No, we're definitely not interested in that. And actually, I think that was the right answer, personally.
Yeah.
So,
yeah, I agree. And so we didn't have time to discuss this to the length that we would have liked to do. There were a couple of positions, let's say, that were put on the floor. One was that if you demand that you can do some sort of a reduced genome, then that requires a huge amount more work. Maybe that's the right goal. But even today, we can't synthesize, we can't even come close to synthesizing a human genome. And then you get into this discussion, the projection. Well, if we brute forced it, we could probably do that in 10 years. And so I was adding to that, let's not only brute force it with today's methods and costs, but say we're going to synthesize some normal human genome, but at considerably reduced costs from today's costs, and some, or even actually reduced from following the current projection of cost reductions, because then we haven't done anything different. So, right, if you take the current cost projections of what it should cost between now and 10 years from now, we want to reduce by 10-fold or 100-fold or 1,000-fold lower than that. But I think the point is that those 20 people in the room had different ideas of what our goal, what the clearly articulated, crisply stated goals of the project are. So that's a message back to leadership.
I just have a little bit of a nuance to that from the discussion. I don't think we were trying to set the goal for GP Wright. We were just wanted to set for ourselves as a working group some idea of a focus so that we could then think about what technologies do we need for that focus. And so we weren't trying to make a decision about that the goal for GP Wright should be to do a wild type human or a non-wild type human.
Thank you for that clarification.